So as many of you are probably aware, we recently lost Georgia Benkart, who is a great mathematician, mentor, and person. She was probably a mentor to many people in this room. That's how I knew her. I was in her research group for the Women in Representation Theory and Non-Commutative Algebra. She was also leading a research group for the women in algebraic combinatorics and really doing research and working with junior mathematicians, especially women, up until the end of her life. So in commemoration of her immense contribution to mathematics and the AWM, we are now going to hear a talk in her legacy presented by Professor Rosa Orellana. Professor Orellana got her PhD at UC San Diego and is now a professor at Dartmouth College. Among her many accomplishments, she was awarded the John M. Manley Huntington Memorial Award for outstanding research by a newly tenured faculty member and helped found the AWM chapter at Dartmouth. Professor Orellana's research is in algebraic combinatorics and representation theory, and she's really an excellent person to give this talk because she's one of the foremost experts in centralizer algebras, which was also one of Georgia Benkart's areas of expertise. So it is my pleasure to introduce Professor Orellana, who will be speaking about the legacy of Georgia Benkart.
It is an honor to be here, and I want to thank the AWM for giving me this opportunity to say a few words about Georgia Benkart. I first met Georgia when I was a second-year graduate student. And I met her at a meeting at MSRI. They had a special year in combinatorics that year. At that point, I had just begun doing research. I didn't know almost anybody in the area. And I don't know if you're aware, but at MSRI, they have connections for women, which is 2 days before the introductory workshop. And that is to encourage, younger women mathematicians to do that type of research. And Georgia was one of the organizers of this. But what impressed me the most is that as I walked in, I was completely intimidated, my first conference ever. And I saw that, that smile, and she came over and said, "Welcome." And she says, "I heard that you're doing your PhD with Hans Wenzel." And that to me was kind of so impressive that she had taken the time to find out something to make a connection with me. It was so striking. And throughout the conference, even she would take time to kind of come and talk to me and tell me how are things going. And I felt like, she really made an impact. So that was my first interaction with her. And this was when I was a second-year graduate student. So I hope I can do justice and tell you a little bit more about how she impacted my life. And I hope that, when I died, I had made an impression on somebody the way that she did on me and how she influenced my career throughout. So when I met Georgia, she was the E.B. Van Vleck professor at the University of Wisconsin in Madison. And there, as you can see, right now, if you go to the MathSciNet, which is not usually up to date with all the publications, there are 134 publications and still counting, some are still coming, and 39 after retirement. She won prizes for, this doesn't have a pointer. She won prizes for undergraduate teaching. She mentored 21 PhD students. She had an early retirement, which took me completely by surprise. I couldn't imagine somebody, she was so young in my perspective when she retired in 2006. And I talked to her about this when she visited Dartmouth. I invited her to come to give our prestigious lecture. She was actually the first woman to give that Kemeny lecture at Dartmouth. And the reason is that you nominate the person. It's not like people don't get nominated, but then it gets voted by the whole faculty. She was the first woman to actually be voted unanimously to give the talk. Anyways, so I talked to her, like, how come she had retired? I'm like, it's kind of like she was still very active. And when she came to give the talk, she had been out 5 years. And she said, sometimes, you have to continue your work in other ways. And I think this is what she wanted to do. She wanted to help improve the opportunities for women, like she wanted to improve the opportunities for minorities. I have been blessed to have had outstanding mentors, and she was one of them. So it does make a difference. So anyways, we talked about it when she came, and I was kind of impressed that, a lot of people retired so that they can stop working, but she actually retired so that she could work harder towards what she thought would make a big difference in the world. So I admire that in her. So just to give you an idea, when she got tenure, under 3% of tenured women at comparable universities were tenure at the time that she received tenure. And one thing that I learned, and it's kind of like it struck me, like as I was reading her eulogy, like, as I was preparing for this talk, is that people don't realize that, how hard it has been, like, to make progress when society sometimes doesn't allow you to make progress. Like, I learned that her mother was a teacher, and that wasn't surprising, right? That she was a teacher. But what I learned is that women were not allowed to continue working after they had children or they had married. Her mother worked at one of the few schools that allowed that. And that was, to me, like, this was 1950s, like, like it doesn't, it's like, so, I mean, she was surrounded by this. Like, there was another woman at Wisconsin at the time that actually her tenure was being held because her husband was in the faculty. So I learned this as I was reading, and I felt, yeah, you have to sometimes stop, teaching. Like in this case, she stopped teaching to make a difference in this. And I thank the AWM for keep fighting this and kind of making it better. Like, it doesn't, in my first conference, it was on functional analysis. The first talk I gave, like, was a room with 100 people, and there were 2 women there. And I have to say, my hands were shaking the whole time. And it wasn't emotion, it was nerves, because I felt so out of place. And when I go to these conferences, like this one, I don't feel that. I feel like I belong. So anyways, let me continue. So Georgia, after retirement, she kept going, like, she became the associate secretary to the AMS. And this was kind of something that was like a lot of work, because you have to plan all the meetings for the central meetings. Every 4 years, you're in charge of the joint mathematical meetings. She also organized meetings with internationals. So for instance, 1 year, she did it with the Portuguese Mathematical Society, and it took place in Portugal. So she was very active doing this. What I found very striking about her is that although she was so busy running these meetings, she would always take time to come and talk to you. and come and say hello with a smile, like, kind of making you feel that you belong. And I want to share with you, like, kind of, I've had many meals with Georgia throughout my career as I, kind of, we were in the same area, usually spoke in the same conferences and things like that. So when she organized a meeting at Fargo in North Dakota, we arrived early, both of us, and we met in the lobby of the hotel. And then she said, "Do you want to grab dinner? Let's go have dinner." I said, like, let's meet here at 6:30. So we met. And she, when we asked, where can we go to eat? We asked, kind of at the person at the hotel. And then they recommended this German place. Like, they said, it's the best. You really, really have to go. And okay, so we said, okay, so how do you get there? Oh, we'll take you. Here is the car. They drove us. They were really, really nice. So we got there and we asked for a menu, and they say, oh, we don't have a menu because all we serve are, sausages with beer. And I told Georgia, well, I don't drink beer. And then she says, I don't eat meat. And I said, do you want to go somewhere else? And she says, it's getting late and we have to be early because of the sessions. She says, I'll drink the beer and you eat the sausage. So this was, I felt like, she was like that. So always making the best of every situation, always, we ended up sharing some fries too, like, and some coleslaw. But, this way we save, we bought one meal and we both ate, right? So anyways, Georgia was, at the time that she retired, she was kind of editor. She was like, kind of at the top of her career, right? And she also, kind of was the editor for the Journal of Algebra, for Communications and Algebra. I interacted with her in this, I submitted papers to the Journal of Algebra when she was, and she was always extremely professional and encouraging. She was like amazing. So she also served in several advisory boards and a trustee for math institutions, like at MSRI. She was mostly in charge, like for improving like the programs for women, right? And I felt, that made a big difference. So anyways, but service to the AWM. She served as president of the AWM from 2009 to 2011. And at this point, I also had a conversation with her, and she was kind of telling me that, kind of at this point, there were a lot of programs for young girls, Sonia Kovalevsky Math Days, they were kind of old, and she was trying to think of ways of how to improve, because it seemed that not many women were making it to the top, like, full tenure professors. And how can you change that? Like, she was kind of like, trying to find ideas. And her thought at the time was, perhaps we need to concentrate there, like make a break there, try to kind of, and that's when, unfortunately, Sonia Kovalevsky Math Days stopped being funded around 2013, right? That was around the time that those things were stopped funding. But, I want to talk to you about the difference that it has made, like the changes that they have done. In 2011, it was the 40th year anniversary of the AWM. And as I was walking, somebody told me, do you think that this association is still needed? Somebody asked me. And I said, yeah, because, if you look at the, big universities, if you kind of look at, we are fortunate that this is changing and, but this has been a lot of work, right, in improving this. So I think it's still needed, and it's still, I'm very grateful for all the work that the AWM is doing to change this. But, so this was the big research symposium. where there were tons of posters, there were tons of talks. It was really, really like, I was there and kind of invited by Georgia. So I feel very grateful to have kind of, had the opportunity to share math with her. So in 2014, she was selected to deliver the AWM AMS Northern Lecture, and she spoke on McKay matrices at the time. And I want to, later I will talk about McKay matrices because that's what we were working about, but I want to say that she had been working on this for a very long time. But I think what made the most difference is that, these women in math workshops, right? Like women in fill the blank. And the first one I think was women in numbers. And I think there was women in algebraic combinatorics was in 2011. So let me show you. So this was the first, the one on top, women in algebraic combinatorics. And as you will notice, that double X, that was Georgia's idea. Like she named this algebraic combinatorics workshop. This was a workshop at Banff in 2011. And at the time, so just to put it in perspective, at the time I had already been tenured at Dartmouth. But I was suffering from confidence issues. I actually was feeling kind of, I had a child recently, right? And I was kind of wondering, like what next? And this is what I wanted to say. Like at this point, a lot of people, they stayed associate, right? Because you already have tenure, right? So you're kind of like already feel comfortable. So I think you need the extra push sometimes, or the extra confidence to let you know that you can keep going and you can do it. And this workshop came at the right time. In 2011, I was getting closer to, a few years to apply for full professorship, but I was lacking complete confidence that I would be able to do it. So I should say that the organizers were Georgia Benkart, Steph Van Willenberg, and Monica Basirani, and I got invited to participate. When I got there, the groups weren't formed, I think the groups could have been formed better, like in terms of by topic, right, at the time. But you have to understand this was one of the first few ones. So they were just putting people together, right, and try to find something to do. But the workshop leader for my group said, I don't know why they put us together. We don't have much in common. And we met for the second day and kind of like, nothing. And she says, maybe we should kind of, try to each look for our own. So I was talking to Georgia during one of the coffee breaks at Banff, and I said, my group kind of fell apart. Like, kind of everybody just kind of dispersed. And she says, oh, come to my group, and this was like the third day of the workshop. And we didn't get a paper out of it, but I got something better. I got introduced to somebody who was working on something very similar to what I was working. And we started chatting during one of these meetings. And this actually started the project that I have been working since then. Like we wrote a paper, and that started there. That was Maud de Vicher, like who I could have never met if I hadn't been invited to Georgia's group by her. So one thing that I admire about Georgia is that she wasn't a pushy person, but she pushed you in a way that let you know that you could do something. So you see, she organized the first algebraic combinatorics, but she didn't go and say, okay, go organize the next one. She didn't tell anybody to organize, but she kept mentioning, do you know when is it going to happen? I think, the next generation should, try something, So, because I think that, as a parent, right, sometimes we do everything for our children, but sometimes it's important to let them know that they can do it themselves. And I think this empowerment was something that was amazing, because she said, the next generation has to go, like, the next generation has to do it, and you can do it. And I was feeling, why me? I kind of, I didn't feel I was at her stature, like, to kind of be able to do something like what she was doing. But she kept saying, no, you can, but the next generation has to do it. That's what she said. And she encouraged Julie, Trisha, myself, and Steph to organize the second one. And you see there was a big time hole, because kind of, I guess we didn't feel that we could do it, right, for a while. But then finally it got organized at another one at Banff. And so another group that she organized was WINART, and this is Women in Non-Commutative Algebra and Representation Theory. And this is what Sarah mentioned, like that group, the other group that she was participating in. And I co-led one of the groups. She invited me to co-lead, which was kind of another way to teach people like how to do it, right? Like sometimes, she could have led it herself, but she said, come, because sometimes you have to, let people know that they can actually do it, okay? And she did that for me. So she said, come, let's do it together, and she at all points, she kept asking me, what do you think we should do? Like, and kind of giving me that confidence that I could actually do it. So this was another one that I participated at. And it was like another wonderful experience. And this one was more successful because Chelsea is, kind of like really energetic. So she said that she was going to do it every 2 years. And it has been every 2 years. They are on to their third one. They just had it this past spring. And so anyways, and Georgia was actually leading in that group. She was leading in that group and for algebraic combinatorics, because this is a picture of my research group with her in another group that we have just started that continues the algebraic combinatorics. But one thing that I want to say about Georgia is that she was willing to contribute in any role. Like, kind of some people feel like, oh, if I don't, I kind of have a big role, I don't participate, right? If I'm not, kind of, she was happy to be an organizer, as you saw. She was happy to be a group leader, but she was happy also to just be a participant. In the second algebraic combinatorics, she was just a participant. And this is the opportunity that I had to actually, we wrote a paper together, or group at that time. The leader was Anne Schilling, but she was happy to just take a secondary role or to take the lead. And when we approached her, because we started a new group. Okay, so this is algebraic combinatorics 3, but as Catherine mentioned at the beginning, we are in this new time where gender is kind of in flux. So anyways, there were some of the organizers felt at the time that having something combinatorics, like kind of like with these chromosomes and things like that, was perhaps not appropriate, right? And that perhaps what we needed was something more inclusive. So we renamed it Research Community in Algebraic Combinatorics. So this should be the Algebraic Combinatorics 3. We were actually, just before the pandemic, Pamela Harris, like she contacts the previous organizers and asks, when is the next algebraic combinatorics? This has been great for me. Let's organize another one. And we said, we don't know. We are all very busy, and we contact Trisha and at the time, and and Julie, and she was like, okay, I'm very busy, I cannot do it. So then we asked Pamela, okay, do you want to join us since you are interested in doing it? And we asked Susana too. And the four of us were thinking about organizing, but then the pandemic started. And we were at that time, we were concerned that, we wouldn't be able to meet in person, and the value was meeting in person. But at that time, I thought, I'm in several research groups that meet online, or they were meeting already, with my collaborator, Mike Sabroki and Schilling. And we meet every week, and we do it. We had been doing it just through, not Zoom, but something equivalent, through some Google. So we had already been meeting, and to me that was kind of working. So I said, perhaps we should do this, because at this time, when the pandemic, the summer after the first year of the pandemic, the European Women in Math put out a letter saying that this was, that a lot of female mathematicians that had to stay with kids because some schools were closed had suffered during this period. And so at this point, we thought that as a response, we would start something online. So, 2 minutes, okay. So anyways, so we decided to organize this. And sorry, I will not get to tell you much about this, but Georgia was one of the leaders. And so this slide probably looks familiar. This is taken from Georgia's slides for the Northern lectures about the McKay correspondence. And basically, if you want to study the finite subgroups of SU2, right? There can be only these 5, right? And basically they are in correspondence with these graphs right here. Oh, yeah, there is a pointer. So they are in correspondence with these graphs, and these graphs basically encode the representation theory of the groups. So each node corresponds to an irreducible representation, and the arrows will correspond to something. But anyways, so basically, sorry. So there are some very nice things. You can define some matrices, right? Based on the graphs. So this matrix, so the way that you define them is as the adjacency matrix of the graphs. And this is called the McKay matrix. The marks are the dimensions of the representations. And so here, these ones is a vector of the dimensions. And one thing that happens is that this vector turns out to be an eigenvector with eigenvalue 2 of the McKay matrix, for the adjacency matrix of the graph. So in 1985, Steinberg generalized this for any finite group. Basically, he defined this, so if you define a representation, so basically what you're doing is taking tensor products, and if you are over the complex numbers, all the irreducible you will have all the representations are irreducible or simple modules. And what you do is you take tensor products. What this encodes is the tensor product. And basically, when you decompose this tensor product in terms of the irreducibles, these coefficients right here turn out to define the McKay matrix, which is simply the adjacency matrix. And by quiver here, so the quiver is because when you tensor, there is an arrow associated. Maybe I'll show you an example in a second. So, but what it turned out, what Steinberg found out, is that if you multiply the matrix times the vector of the dimensions, this turns out to be an eigenvector, and and right here, the eigenvalue turns out to be the dimension. But that this generalizes, and you see these ones are kind of columns in the character table, if you know what that means, which is an invertible matrix. And the eigenvalues turns out to be the characters of this representation at the different values. So in 2018, Benkart and Moon started to study walks on graphs related to groups. So kind of like, counting the number of walks. But what this means, if you have done, some graph theory, it means that you're finding the powers of this matrix, right? And the entries actually give you the number of walks. So she was studying this, and she found a lot of relationships to invariant theory, probability, and using Schur-Weyl duality. In 2018, Benkart, Clevans, and Brauner, studied Mackay quivers and Mackay matrix with relationship to chip fighting. In 2021, Benkart, Diaconis, Liebeck, and Tiep found relationship between Mackay matrices and Markov chains, because you can define some probabilities, you see, because here, what you do, each of these is a representation, and you take a tensor, and basically the arrows indicate to which ones you can go after tensoring, which ones occurred in the tensor product, and you put a number on the edges indicating the multiplicities. So here there are some multiplicities too, indicated by two arrows. So you can define that. So you can actually define this. So when she came to, so in this project right here was the one she was leading at Winard at the time of her, well, this was a publication, but it was continuing, and they were looking at finite half algebras. And so she brought this project to us, and the question that she was asking is, what other algebraic structures can we do in which Mackay matrices would be defined, right? And the questions that she was asking at the time was, is the Mackay matrix diagonalizable? When is it symmetric? Are the eigenvectors related to characters in some ways, in the similar way as groups? So since I'm running out of time, I'm not going to tell you that we did work for monoids, like, kind of like in our project, and we found some new examples, right? We were working on, at the time of her death, we were working on trying to study counting paths. We were trying to answer a lot of questions. She left us with a lot of questions that she wanted us to answer. And this is still work in progress, like it's not done. But since we are out of time, what I want to say is that she led a very meaningful life to me, because she made a difference in me. Like, I was very sad to hear that she had died. And, at the time I was doing physical therapy because I was having back pain. And I kept telling her that I couldn't sleep because of the back pain, and that I was going to physical therapy. And she never mentioned to me that she was also having back pain. And although she looked a little bit frail towards our last meetings, I kind of felt like, she never said anything. She never complained about things. It's kind of, it felt very sad. It was very devastating for me to hear, because we were kind of, getting, trying to organize the next meeting, right? And all of a sudden I got this news that she was dead, like, kind of from the AMS. But, the only sad thing is that I never got to say thank you, like, for everything she did, right? Like, sometimes I feel we don't thank the people that make the most difference to us. And I had a lot of mentors, and sometimes it's not that I take them for granted, but I forget to say thank you because we think they are going to be there forever. Thank you.